In this video, we're going to cover the properties of limits. Let's say we had two different functions and knew that the limit of f of x as x approaches c is equal to a, and that the limit of g of x as x approaches c is equal to b. So according to the sum rule, if we were asked to find the limit of f of x plus g of x as x approaches c, another way to write this is to take the limit of each function independently and add them together. So we will have the limit of f of x as x approaches c plus the limit of g of x as x approaches c. And we know that the limit of f of x as x approaches c is equal to a. And we know that the limit of g of x as x approaches c is equal to b. So we will get a plus b. Now, what if we subtracted the two functions? Well, we're doing the exact same thing as the sum rule, but this time we're subtracting. So we will get a minus b. Now, let's say we took the limit of some constant times the function f of x as x approaches c. Well, according to the constant multiple rule, that's the same thing as writing k times the limit of our function f of x as x approaches c. And this will equal k times a. Now let's say we want to multiply the two functions together. Well, using the same idea, we will take the limit of each function independently, then multiply them with each other. So we have the limit of f of x as x approaches c times the limit of g of x as x approaches c. And this will equal a times b. Now what if we wanted to divide the two functions? Then according to the quotient rule, we will take the limit of f of x as x approaches c divided by the limit of g of x as x approaches c. And we will get a divided by b. But as a disclaimer, this property only works if the limit of g of x as x approaches c is not 0. Because if the limit of g of x as x approaches c is 0, then this value is undefined. Okay, so what if we took the limit of f of x to some power of n where n is a positive integer as x approaches c? Well, that's the same thing as writing the limit of f of x as x approaches c all to the power of n. And that's going to equal a to the power of n. And lastly, if we had the nth root where n again is a positive integer of f of x as x approaches c, this is going to equal the nth root of a. Now that we got through all these properties, let's do a few problems. So for our first problem, we have the limit of x cubed times 2x as x approaches 3. So you see we have two different functions being multiplied to each other. So that means we have to use the multiple rule. So this equals the limit of x cubed as x approaches 3 times the limit of 2x as x approaches 3. And now we can use direct substitution to solve these limits. So this equals 27 times 6. And this will equal 162. Now let's solve the second problem. For the second problem, we have the limit of x divided by 12x as x approaches 24. So we can use the quotient rule. So this will equal the limit of x as x approaches 24, all divided by the limit of 12x as x approaches 24. And we can use direct substitution to solve this limit. So this will equal 24 over 288. And this will simplify to 1 over 12. Now let's do the third limit. So we have the limit of 2x as x approaches 3. And according to the constant multiple rule, if there is a constant in front of our function, then we can factor it out and multiply with the limit. So we have 2 times the limit of x as x approaches 3. And this will equal 2 times 3, since we use direct substitution to plug in the 3 into the function. And this will give us 6. Now let's look at the fourth problem. We have the limit of x to the fourth minus 3x squared plus 4x as x approaches 1. So here we can use both the sum rule and the difference rule to solve this limit. So this will equal the limit of x to the fourth as x approaches 1 minus the limit of 3x squared as x approaches 1 plus the limit of 4x as x approaches 1. And now we can use direct substitution to solve this limit. So this will equal 1 minus 3 plus 4. And this will equal 2. And lastly, we have the limit of 2x to the power of 2 as x approaches 2. So we can use the power rule to solve this limit. So this limit will equal the limit of 2x as x approaches 2, all to the power of 2. So this will equal 4 to the power of 2, which simplifies to 16. For these 5 problems, there are other ways we could have solved the limits, but I wanted to show you how we use these limit properties. So in a recap, if we knew that the limit of f of x as x approaches c is equal to a, and that the limit of g of x as x approaches c is equal to b, then we will get these limit properties, which will be useful when we solve future limit problems. Thank you for watching this video and hope to see you next time.